Section 2.3 involves conditional statements. A conditional statement is basically an if-then statement. You have an hypothesis that follows the word if, and you have a conclusion that follows the word then. You can write this as an abbreviation of P then Q. Like, for example, if you clean your room, then you can go to the movies. This would be your hypothesis, and this would be your conclusion. This determines whether that happens. So if you clean your room, then you can go to the movies. It's not, oh, if you go to the movies, then you can clean your room. So this happens first. This is your hypothesis, and that happens as a result of this. So if you said this is statement P, you clean your room, and this is statement Q, you go to the movies, this right here says if P, then Q. If you clean your room, then you go to the movies. Sometimes the word if and then are not used, and you would have to then still figure out which one comes first. The Tigers will play in the tournament if they win their game. If they win their game is your hypothesis, because that has to come before them playing in the tournament. So how they do in this game determines whether they play in the tournament. So you could rearrange this and says if the Tigers win their game, then they will play in the tournament. Conditional statements have truth value. They are true unless they can be proven false. And the only way that they can be proven false is if the hypothesis is true and the conclusion is false. So in other words, on this statement, you clean your room, but you don't get to go to the movies. Okay? If we just had that previous statement, P then Q, then what you have done is you have supported your part. You've cleaned your room, but your parent perhaps does not let you go to the movies. So you did the hypothesis, but what they promised you would get when doing the hypothesis didn't take place. So the truth value of this is false. So let's practice a few. Remember, the only way you can get a false is if the conclusion is true, or if the hypothesis is true and the conclusion is false. So here's the statement that they give us. If you get 100% on your test, then the teacher will give you an A. So this is your P, then your Q. Okay, 100% on your test is your P. The Q is the teacher will give you an A. So I'm going to determine the truth values for the following statements based on what they have already given me to be true. So I get 100% on my test, and the teacher gives me an A. Okay, that completely supports this. You get 100%, you get an A. So the truth value there is true. You get 100%, and the teacher gives you a B. Oh, that's not true, because you did what you were told that you had to do in order to get an A, but you didn't get an A, you got a B. So this is false. Okay? You held up your part, the teacher didn't hold up their part. You get a 95% on the test, and your teacher gives you an A. Well, the truth of the matter is that isn't supported by this hypothesis, because this says you had to get 100%. Nowhere up here does it say what happens when you get 95%. So therefore, you can't prove it wrong, so it's still true. It doesn't tell me up here what happens when I get 95%. So we're going to assume that that's still true. You get 85%, and your teacher gives you a B. Again, the 85% is not supported by this hypothesis, so you can't prove it false, so you have to say it's true. It's kind of like the concept of innocent until proven guilty. They're true until they can be proven false, which means You did the hypothesis, but you didn't get the conclusion that was promised. Let's do another one. Okay, here's the information they give you. If Yukon rests for 10 days, his ankle will heal. This is the P, then the Q. Yukon rests for 10 days, and he still has a hurt ankle. So you did the P, but the Q is not what you received. So you did the hypothesis, but you got a different conclusion than what was promised. So this is false. Yukon rests for 3 days and he still has a hurt ankle. Well, resting for 3 days is not the same as resting for 10 days, so I don't have the hypothesis, so I certainly can't prove that it's true or false, so it has to be true. Okay, unless you can prove it false, it stays true. Yukon rests for 10 days and he does not have a hurt ankle. Well, that's exactly what was promised up there. That's true. Yukon rests for 7 days and he doesn't have a hurt ankle anymore. This is not the hypothesis up here, so we cannot prove it false. So we have to say it's true. Okay? The only way, again, that you can prove it's false is if you have the hypothesis, but you get a different conclusion. There are related conditional statements, and each one of these has their own truth value as well. So let's say I have a conditional P then Q statement. If two angles have the same measure, then they are congruent. This is P, this is Q. A converse statement says Q then P. So you can make this statement: if two angles are congruent, see, that's the Q part, then they have the same measure. That is what we call the converse of the conditional statement. So if I go back here, let's talk about the truth value. If two angles have the same measure, then they are congruent. That is true, based on what you remember about the definition of congruence. If two angles are congruent, then they have the same measure. That is also true, based on that definition of congruency. The inverse statement is the negation of P, then the negation of Q. So I go back to this original and I say, if two angles do not have the same measure, then they are not, oh, I did this back, they are not congruent. And that also is true. All right, then the contrapositive is the negation of Q, then the negation of P. So I'm going to come up here to this one because that's Q then P. So I'm writing the negation. If two angles are not congruent, then they don't have the same measure. That is also true, because those two terms, congruent and having the same measure, are used interchangeably. Okay, let's look at another example. All right, it says write the conditional, converse, inverse, and contrapositive of the following statement and give its truth value. So here's my statement. all squares are rectangles. So the conditional statement, which is P then Q, okay, that's conditional, says, and I'm going to abbreviate there, if you have a square then you have a rectangle. And that is true because every square is a rectangle. Okay, the next one we have is the converse statement, which is just the reverse, Q then P. So now I say, if you have a rectangle, then you have a square. And the truth value here is false because not every rectangle is a square. So I can have a rectangle and have it not be a square. The inverse is going to be the negation of P, then the negation of Q. So if you do not have a square, then you do not have a rectangle. And that would also be false because if I don't have a square, I might have a rectangle, okay? So I can have a shape that isn't a square, but it's still a rectangle. And then I have the contrapositive, which says the negation of Q, then the negation of P. So if you do not have a rectangle, then you do not have a square. And that's true because all squares are rectangles. So if I don't have a rectangle, then there's no way that I can have a square. All right, these also can be put on the truth tables. Now these are when the actual statements are not known. So I don't know what P stands for and I don't know what Q stands for. So again, I have either a true or false value for this, for the truth value. So I'm going to put my pattern out. And that covers all different possibilities. Now, remember, the only way to have a false is if my hypothesis is true and my conclusion is false. So here's my conditional statement. Okay, so here's my hypothesis. So I have a true and a true, so that's true. I have a true and a false, so that's false. Remember, that's what I'm looking for, is true, then false. That's the only way it can be false. Other than that, it's true. So this one is true, and this one is true. This one is my converse statement that says Q, then P. So this time I'm going this way and then this way. So this comes first and that comes second. That's true. This is true. This is the only one that's true, then false. So that one's false, and of course that one's true. So you're going to get one false and everything else true. Now the negation, and I'm going to come over here and I'll do the negation right next to it. So this would be false, this would be false, this would be true, and this would be true. Because remember, it has the opposite truth value. The negation of Q, I have a false, true, false, true. So I am looking for this, then this. And I'm going to go down here. The only one that's true than false is this one. So that's false, and everything else is true. Then I'm going to go backwards. I'm going to go from this to this. So I'm looking for the true, then the false, which is this one. So this one's false, and everything else would be true. All right, your homework on this is page 78 through 79, 16 through 44 even.